This is our project. It consists of two parts, the device tester and the characterizer. The device tester has been successfully implemented using MSP430. Shown here are the components which we are going to test with the device tester. A device tester is capable of identifying the various shown components accurately, and along with it, it even measures the voltage drop of LEDs and the values of resistance. Furthermore, any device under test can be placed in any pin configuration in the three testing pins. This device tester is also capable of identifying specific pins of semiconductor device under test. For example, base, collector, emitter of a BJT and P and N side of a diode can be identified.
The second part consists of a device characterizer circuit which plots characteristic curves of transistors. The characterizer part has been successfully implemented for NPN transistors. The hardware for MOSFETs and PNP transistors along with device tester has been incorporated on a single board, but the software part for mentioned PNP and MOSFET is under progress and hence not shown in the video. To make the circuit power efficient and universal to characterize all types of semiconductor devices, a custom power supply has been designed to meet the specifications. The TI components which have been used in the circuit are LM723 linear switching voltage regulator IC, LP2950 5V low dropout voltage regulator, LM1117 3.3V low dropout voltage regulator, MSP430G2553 low power mixed signal microcontroller, LM358 dual operational amplifier, TL082 dual operational amplifier with high slew rate.
Now we will demonstrate the use of device tester circuit. We have taken a PNP transistor AD140, placing the transistor in the test socket and pressing the reset button. The circuit takes 2 seconds and displays the result of DUT. Here you can also notice that the specific LEDs of the DUT have been shown with respect to the pin mapping indicated on the board. Now we take a NMOS. We put the NMOS in a similar fashion and pressing the reset button gives us the results. Here you can see it is an NMOS with gate and source and drain indicated. By inverting the DUT pins of the same device, we have got the same result, but now as you can see the source and the gate pins have been inverted. We are taking a diode and we can place the diode in any of the two legs. Here you can see that it displays the result as diode and also gives the pins positive and negative. To show that our circuit is not pin or configuration biased, we again put the diode in a different configuration and a different polarity, and again we can see that it again shows us correct results. Now the DUT is a 2.7V Zener diode. Our circuit also detects and measures the values of resistances. Here we are taking a 3.3K resistance. The value shown by our circuit is 3143 ohms. We are reversing it and getting another reading of the resistor. And we can see that the result is still the same. The next DUT is a green LED. Placing the LED in any fashion and pressing the reset button gives us the result. We can see that the positive and negative LEDs have been indicated along with the working voltage of the LED. In this case it was 2.76 volts. Now we are placing a red LED. And the results follow in a similar fashion.
Now to show the robustness of our system, we'll demonstrate the device tester with LDR as the DUT. Just like earlier DUTs, we have placed the LDR in any fashion and measure its resistance under different light intensities. Under ambient light condition, its resistance turns out to be around 7K. Now placing a flashlight over it, its resistance decreases, which now becomes 2.6K. Now we will observe the LDR under low light condition and by creating a shade over it. Now its resistance become around 10.6K.
Now we are going to demonstrate the tracer part of our project. For this, we need an oscilloscope operating in XY mode. We have taken an NPN transistor and firstly we test it for its legs using the tester circuit. The oscilloscope probes of channel X and Y have been connected appropriately to the tracer circuit outputs. Particular leads of the tracer are connected to the corresponding leads of the DUT. Switch on the circuit and observe the output on the oscilloscope. The oscilloscope is adjusted till a proper curve is seen on it.
With this, our presentation comes to an end. Thank you.